All right, guys. All right, so for our last part, we're going to be writing equations of lines. And this is where I feel like you might do things a little bit differently than I do. And that's absolutely fine. It's whatever works for you, okay? And so what I use primarily to turn equations into slope-intercept form is actually a starting point of point-slope form. And what point-slope form is, it's y minus y1 equals m times x minus x1, okay? And so we're going to take that original equation and we're going to turn it into slope-intercept form, which is y is equal to mx plus b. So the reason why I start with point-slope form is a lot of the times that's what you're given, right? I'm given a slope, I'm given a point, all right? So this is a really good starting point, all right? So I'm going to take this point, and this is my x1, y1, okay? And I'm going to plug into y minus y1 equals m times x minus x1, okay? So I'm going to take my y1, which is negative 10, and I'm going to plug it in. So I'm going to have y plus 10 is equal to my slope of 1/5 times x minus 5, which is my x1. Now I look at my diagonals and I see that 5 goes into 5, so this is going to distribute nicely, okay? So I'm going to have y plus 10 is equal to 1/5 x minus 1. And so the goal is to get y by itself again. So I'm going to subtract 10 on both sides. And I'm going to get y is equal to 1/5 x minus 11. Okay? Now, if you would have just done this using slope-intercept form, all right, you would have still got the same answer, just different methods. Okay? Now, I'm going to pop down to example 3. And this time I'm given 2 points. All right? And so the first step should be you should find your slope. All right? So I'm going to do 10 minus 1 all over negative 1 minus 5, and we get 9 over a negative 6, which simplifies into negative 3 halves. Okay? So once we have our slope, we're going to pick one of these points, and it doesn't matter which one to plug it into point slope form. And so I'm going to pick 5, 1, and this is my x1 and my y1. All right? So I'm going to get y minus 1 is equal to negative 3 over 2, and then x minus 5. Okay? Now, if I look at my diagonals, I notice that the 2 doesn't go nicely into the 5, all right, which means that we're going to get some decimals or some fractions. So what I like to do is I actually like to get rid of my fractions so I don't have to deal with them. And so to do that, my rule is you actually multiply by the denominator, okay? And you multiply everything on the outside of the parentheses by the denominator. So I'm going to start by multiplying my negative 3 over 2 by 2, okay? And that cancels out the 2 on the denominator. But in order to do that, I also have to multiply both things on that left-hand side also by 2. So I'm going to get 2y minus 2 is equal to, and because my denominator canceled out, I'm actually going to take this 3 and distribute through, and I'm going to get negative 3x plus 15. So from there, I'm solving for y, so I'm going to add my 2 over, and I get 2y is equal to negative 3x plus 17. And I want you to keep it in fraction form because I'm going to divide out the 2. And my final answer is y is equal to negative 3 over 2x plus 17 over 2. Okay? Okay. Now, we're going to come down here, all right, and we're going to talk about how to find the equation of line of parallel and perpendicular lines, okay? And so we're given this original equation here, and the thing about this is all we want is the slope from it. Because we want the equation that's parallel to it, which means that it has the same slope. So the slope that I'm using is 1 over 6. And once I have that, I don't care about that original equation anymore because I have my slope and I have my point. So I'm going to plug into point slope form, which is y minus 10 is equal to 1/6 times x minus 6. And once again, I look at my diagonals. All right, I look at my 6's. I notice that 6 goes into 6 easily. So I'm going to now distribute through. So y minus 10 is equal to 1/6 x minus 1. All right, I'm going to add the 10 over, and I get y is equal to 1 over 6x plus 9. Okay? Now, the next one is about being perpendicular. Okay? So same idea for this one. We only want that slope, but we want the perpendicular slope to it. So if the slope of this line is 3 over 5, then my perpendicular slope is the opposite reciprocal, which means it's going to be negative 5 over 3. And so once I have that, I have my slope. All right, I don't care about that original equation. I have my point. I'm going to plug it into point slope form. So I have y plus 9 is equal to negative 5 over 3 times x plus 12. Okay? So I look at my diagonals once again. All right, I see that 3 goes into 12, so I'm going to distribute through. So I have y plus 9 is equal to negative 5/3 x. 3 goes into 12 4 times. All right, so then negative 5 times 4 is a negative 20. And then I subtract my 9 over, so I get y is equal to negative 5 over 3x minus 9. Okay. Now, for my last two, I'm going to just come down to this last one right here. All right. And so the easiest way of doing this is just recognizing what slope-intercept form is actually asking you to do. And that's to find your slope and find your y-intercept. So if you can find your m and find your b, all right, then you can just plug into slope-intercept form. So my b is my y-intercept. So my b is 2. And then my slope, I have to find another good point, which this negative 5/3 looks great. And I do rise over run. So I recognize right away that this is a negative slope, all right, which means that my answer is going to be negative. So I'm going to go up 1, but then I'm going to go to the to the left, negative 5. So my slope is negative 1 over 5. And so plugging into slope-intercept form, you get y is equal to negative 1 over 5x plus 2, and that's your final answer. All right, so there you have some U-try. And then our last little bit here is, we can actually come back to that just so I have enough time, all right? But this is probably one of the tougher portions.